We're told that O is the midpoint of WE, or segment WE, and segment QD. We're going to prove angle 1 congruent to angle 2. This is very similar to a question that we've seen earlier. We've seen this picture before, just given different information. What we always want to do is look for vocabulary in our given information. I've got midpoint there, so I look at O being the midpoint. It says O is the midpoint of WE, which is that segment right there. Okay, so if it's a midpoint, it's going to cut that segment into two congruent parts, and those congruent parts are WO, should be congruent to OE. Alright, and likewise, it says that O is the midpoint of QD, which is that segment right there, so I'll say QO is also congruent to OD. Alright, and that's going to be the definition of a midpoint. Alright, so instantly, we've got quite a bit of information here. We know that, congruent to that, and that segment's congruent to that segment. Okay, so you got side so far. And looking at our picture, we should know that this piece of information here is hidden in the picture. They're vertical angles. So I want to say that angle QOW is congruent to angle EOD. And my reason is that vertical angles are congruent. And once I say that, I can say the triangles are congruent by side angle side. So I'll say triangle QOW is congruent to triangle EOD by side angle side. That's not what we wanted to prove. We wanted to prove actually angles on the outside congruent to one another. Alright, so thinking about how I would go from inside the triangle to outside the triangle, I want to look at angles that are close to angle 1 and angle 2. I look at that angle there and that angle there. You should know something. If you know these triangles are congruent, you should know something about those two angles. Those two angles that I just highlighted, QWO and angle EDO, should be congruent because they're corresponding parts of congruent triangles. So I'll say CP, CTC. Now what we want to do is, since I know those congruent, I want to see if I can show that angle 1 and angle 2 are congruent. Okay. So the process involved in this would be looking at angle QWO, put it in red here, looking at that angle there, and angle 1, and what do I know about those two? They form a straight angle. They form that straight line. Okay, so those two angles should have to 180. So I'll say measure of angle 1 plus measure of angle QWO is equal to 180. Same thing over here with these two. That angle and that angle form a straight line. So I'll say measure of angle 2 plus measure of angle EDO is equal to 180 degrees. And this is just simply the second part of your angle addition postulate. Okay, so here we see a pattern that we've encountered before. I want to set those two things, since they're both equal to 180, I want to take that part and that part and set them equal to one another. So step 7, measure of angle 1 plus measure of angle QWO is equal to measure of angle 2 plus measure of angle EDO. Again, that's substitution. Better yet, we'd call that the transitive property. Okay, again, I'll accept either one of those. The pattern always tells us once you have something that looks like this, two things equal to two things, you want to try to subtract something. So I'm going to look at what I can subtract from both sides. If I look at, I want to look throughout my proof and see somewhere I've been told that one of these angles on the left-hand side is equal to one of these angles. And that's right here. We know measure of angle QWO is equal to the measure of angle EDO. Okay? And I'm going to change them to measurements. I'm going to go from step 5 to step 8. Okay, I change them from congruency to measurements that are equal. All right, and the reason I want to do that is because eventually I'm going to subtract, and I can only subtract measurements from measurements, or values from values. So step 5 and step 8 are really paired together. I go from congruency to equality. Now that I have that, I can get rid of that and get rid of that, and I'll be left with measure of angle 1 equal to measure of angle 2. So actually getting rid of those things, that process, since I subtracted the same thing from both sides, it's subtraction property of equality. And then once I have measurements equal, I can always state that the angles are congruent through the definition of congruency. Right? And that's what we wanted to prove.